7.6 graphing quadratics in standard form, which we've seen and we loved so much. Ax squared plus bx plus c, it can equal whatever you want. Y can equal y, but usually we want this to equal 0. Changing a quadratic into vertex form, which I guess we haven't done yet, but this completing the square stuff has come back on us. So what we're going to do is, the first thing we got to do is we kind of need to separate the c from these first two terms. And then if there is a coefficient of x squared, which is showing as a, then we got to factor that out. And then we complete the square with whatever's left right there, because we don't want that a.
Where do we get an h?
Yeah, so this is vertex form, which is what completing the square will do. The c, once we do the completing the square, that's what it's talking about right here. Once you complete the square, then the c will be combined with whatever else you have to do to balance this out, so that really you add 0, which may not make sense right now, but hopefully it will by the time I finish, because we're going to need it. But the completing the square thing is coming back to us. So divide all terms by a if we need to. I really don't do it that way, or not anymore anyways. I just kind of look at separating stuff, getting the a out of there, and then completing the square, which kind of combines with step 3 right there. Again, that may not make sense, but hopefully an example will help. Here, we've talked about parabolas and then kind of how they're graphed. The vertex, I think we've seen this before, but the vertex is at this ordered pair HK. That's where the vertex is. So
That was in 7.5.
yeah, it seems like we've seen it. So HK, that's the vertex, and that's good to know, because once we have the vertex, then we also know where the axis of symmetry is, which can be very useful. Okay, to complete a square, let's say that you had some x squared and plus bx right here. B is some number. Then to complete the square, what you need to do is you have to add. You're going to divide it by 2 and square it, but you're going to add the b. I shouldn't use green, but it's the b value divided by 2, and then that is squared. Now, of course, since you're going to do it here, you'd either have to do it on the other side of the equation or zero it out by subtracting it out on the outside as well. So we can't just do this.
That helps a lot, what you just did.
Now, we know this is to complete the square. That makes this a perfect square trinomial, which then means that you'd have x, and this is all squared, but it would be, I guess, whatever the sign is right here, plus or minus, and then you'd have the b over 2. Right here. Whatever that is really what goes right there. Okay, now in the vertex format, of course, there's a minus, so if we ever see this plus, like I was talking about, then we know that the h is going to be a negative. This is just to relate back to what we saw in 7.1 when we completed the square. All right, let me specify. So there would have been a c right here, right? There would have been a plus c right there, and then you would have had to have also subtracted b over 2 squared. I know that's getting a little congested in there, but remember this. What I did right here, that's something that I placed that into the equation, so I'd have to zero it out by also taking it away. Right. So something like this one, you can see right here that it's not showing a c value. It has one, it's just not showing it. It's plus 0. And again, why am I putting the plus 0 so far away? It's so that I can do the completing of the square right here. Now, of course, I've got plus 0, which is nice. But usually there will be something that you can see, not some kind of phantom value. Usually there'd be something right here that you could see that's being added or subtracted. Okay, so this is technically standard form. We're going to change it into this vertex form. It's going to have exactly the same value. It's just going to be in a different format so that we can see the vertex, and that's going to be convenient once we start graphing these again. So I would look at this, and I would look right here. I'm putting parentheses around those first 2 terms because I need those 2 terms to complete the square. So to complete the square, we take that middle term, which is negative 4, and remember we divide it by 2 and then square it. Okay, now that's because of the coefficient of x squared being a phantom 1. But yeah, it's always divided by 2. Whatever that b value is, which right now is negative 4, divide it by 2, and then square all of that garbage. Now from this, though, this is important as well, the 4 divided, the negative 4 divided by 2 gives me negative 2, which is squared. That negative 2 I'm going to need later. But this means that its overall value would have been just an individual 4, positive 4. So right here I would say, look, I'm going to have to add 4 right there. But like we've seen before, and I'm not doing this as a principle of equality anymore. I'm doing it on one side. I can't just add 4 to an equation like this. I can't just put it in there myself, unless it was there already. If it's there, then I have to balance that out by zeroing it out by subtracting 4 out here on the outside as well. Okay, so this is what happens. Now we have completed the square here. We know that by completing the square, this trinomial is a perfect square trinomial between x, and then remember that negative 2 right there. You could factor this out if you'd like to. You're welcome to do that, but I'm not going to because we've seen that. And that, again, is a squared. It would have been x minus 2 to the power of 2 because it's a perfect square trinomial. And then I take the 0 minus 4 right there, and that's going to stay on the outside. So I now have y equals this quantity, x minus 2 squared, and then that minus 4. And this has been changed now into vertex format, which if I wanted to, not that I'm saying I do, but if I wanted to graph this, I could say, look, I know my vertex right now is at 2, negative 4. Okay, graphing the parabola defined by, this is the vertex format for our quadratic, our trinomial.
May I ask
This
one
is
quick
vertex
question? I know
form. Okay, so again, the nice thing about this format is we have this h and this k, which is part of the vertex right here, h and k. Once you know those, then you have your h and k. And it's important to remember the minus sign does not make the h negative. If it were a plus, it's like doing minus a negative, which makes the h, that would make the h a negative. I won't show that. If I ever see a plus sign right here, we just need to know that that is going to make the h a negative, okay? Because the expectation, we have enough experience with that right now. So this one is plus. So like on that last example where it was minus or plus, right? If this is plus, then the k is positive. If it's minus, the k is negative. So this operation right here does apply to whatever the k is. So the parabola has the same shape as y equals x squared, which we've seen. Yeah, you can see parabolas like this. You can see parabolas like that. Doesn't matter. Okay, we've seen parabolas. The axis of symmetry, of course, is just wherever this h value is because it has to go straight through the vertex. The vertex is the very tip of the parabola. So if I took those two red ones that I just drew, and we're making some assumptions here, but that point right there would be the vertex, or this one right here would be also the vertex. Okay, so the axis of symmetry, which is what it's talking about here, it has to be symmetric through that line, meaning it reflects or mirrors itself over this line. Or if it were on this one right here, again, it would just kind of reflect over this line right here. So we've seen this before also. If a is positive up here, the parabola will open upwards like this one. If a here is negative, then it opens downwards. We don't really necessarily need this stuff. Or this stuff right here. I mean, this is stuff that you can play around with if you have a graphing program. But I don't know a lot of students that take extra time to actually like research that stuff or play around with it. Like, who's going to go home and play around with math? You know what I'm saying? You do risk social ostracization if you do that, which I've gotten used to because I'm a math nerd. You know, this one right here, it is again in standard form. And let's identify the values on this one, which I didn't quite do on that last one. But here I've got an a value it's a phantom 1. Not that I really care. I would like that to be a 1, by the way. The b value here is negative 4. And then my c value is negative 12. Now this is important with particularly the b value right there, because the coefficient of x squared is already a 1. You could make it a phantom 1. But that b value is going to stay the b value even in the completing of the square right there. So let me give myself some space here. I don't really care about the f of x. I know that's just really y equals. for the equation part of that. So I'm going to take this equation, x squared. I may have to take up some extra space here, but again, I'm separating this negative 12 or minus 12 over here so that I can have some space to complete the square. All right, so I focus on just the first two terms. If I add or subtract anything to this to complete the square, which I am, I've got to do the opposite out here to zero that out, okay? So right here, I gotta find the value that I've got to add or subtract to complete the square. So remember, this is where we take the b value, which we know is negative 4. We're going to divide it by 2 and square that. So negative 4 divided by 2, we've seen this already. That is the same as negative 2 to the power of 2, which has an overall value of 4. Now I'll keep in mind that negative 2 in purple, but this means that to complete that square, I would have to add 4. Now that's inside the parentheses, but since it's on the same side of the equal sign, I've got to zero that out because I can't just add 4 arbitrarily, randomly. I would have to add 0, which would be... One sec. So I would have to show the minus 4 on the outside as well. So the plus 4 that I have right here and this minus 4 right here zero each other out so that I have not changed the overall value of, I'm going to call it an expression, but it comes from this equation right there. So from here, now since this is a perfect square trinomial, and you're welcome to factor it out if you'd like, which I'm not going to do. Again, you've got the x. So you could, here's what I'm saying. You could take the 4 and say, well, negative 2 times negative 2 adds up, or it multiplies the 4, but adds up to negative 4, but that negative 2 just goes right into the perfect square right here, okay? And again, that negative 2, you could have just said, well, I knew that was going to be b divided by 2. That's fine. Then, when you say up here, well, negative 12 minus 4 is going to be negative 16 right there. Well, this is what y equals. And this is great news. In fact, I'm going to take that minus sign from the 2 and just solidify it in black so that I can see specifically my vertex h and k. So the h there is 2 because remember, it's supposed to be minus in the vertex format right here. So it's just a positive 2h, or x value, for my vertex. And then the y value, it does take that negative as its sign. So it's going to be a negative 16. Boom. So that's my vertex. So let's rewrite that. So we got y equals, again, it'd be x minus h squared, and then plus k.
So the vertex is h and k, right?
The vertex is h and k. Boom. So I've got that equation, which is great. For the x-intercepts and the y-intercepts, I don't care about this equation. I just use it for the vertex, pretty much, kind of. I also use it for the line of symmetry. So I'm going to skip those next two and go to the line of symmetry here. The line of symmetry is always x equals, and then whatever your h value is, which is showing is 2, x equals 2. That would be a line, a vertical line, that goes directly through the vertex, which is what it has to do. It's the line of symmetry because it mirrors one side of the parabola onto the other side, if you want to look at it like that. So we got our vertex, we've got our line of symmetry, which sometimes is called an axis of symmetry, if you care. But now we need our x-intercepts, and are the ordered pairs. So it's saying pairs, by the way. Sorry, this got a little cluttered, but it's saying pairs, which means that I should expect 2. Why am I expecting 2? Because it's x squared. So I should expect 2 solutions from this, okay? And then we can find the y-intercept. The y-intercept's the easiest, in my opinion, with all this stuff. But let's give ourselves some more space. Maybe that's what I should have done before. Let's go back to the original equation, because like I said, the vertex format is great for vertex, not so great for x-intercepts. So I would have had x squared minus 4x minus 12. Now, the unique thing about x-intercepts, so again, I am expecting 2 of these, but with x-intercepts, the y values are always 0, because on the y number line, it would be 0. It has no, it's not up or down from where y is 0. And it's also on the x-axis. I'm saying the same thing over and over, but that means that this equation would just be equal to 0 because, remember, it was showing y equals that stuff, or f of x, I know, but y is a lot easier to write.
So is,
But my y value then is 0. So let's factor this out. Now, the great news is that the coefficient of x is a phantom 1. So when I factor this, when I find two factors of negative 12 that add up to negative 4, I should have my two binomials, right? So I would split this up into negative 6 and positive 2, which if I multiply, I get negative 12. If I add, though, I get negative 4, and that's good. So I get negative 6 and then positive 2. So we've seen this before. I need to solve this. Both of these factors, or binomials in this case, need to be 0, right? So that means that if I were to take this x minus 6 and make it equal to 0, if I could get it to equal 0, it would be true. It would make the equation true. So I'm going to add 6 to both sides, and then x equals positive 6. And then also, over here, if I could get x plus 2 to equal 0, that would be fine. So I would subtract 2 now, and I get x equals negative 2, right? Because those zeros zeroed out. So I have two x values that are also known as the roots, which now I can fill in as my x-intercepts. I have positive 6 and negative 2. Okay, the last thing we need is the y-intercept. Now again, we're going to use the original equation for the y-intercept. So we want y equals, it was x squared plus, or minus 4x minus 12. Now, with a y-intercept, which is similar to an x-intercept, in that one of the values is 0, but for a y-intercept, the x value is automatically 0. And so, I say, well, x is 0 right here. So I can go into my equation, and if I wanted to find that ordered pair, I just replace my x's here with zeros, and then I solve this. Now, some of you that are familiar with this already know that 0 squared is 0, negative 4 times 0 is 0, 0, 0, 0, y equals negative 12. After simplifying that, you're welcome to put it into a calculator, but I promise you're going to get negative 12 if you type it in right. So 0, negative 12, and by the way, I could have, once you get enough experience on this one, you could have been like, look, I just know I'm going to pretty much cross out all that garbage for my y-intercept, and then I know the y is just negative 12 right there. Again, that may take some experience before you get that far, but hopefully you find out sooner than later, because the sooner you do, the more you can focus on other things. Yeah, and that's a great point. You could have used the quadratic formula for that, would give you the x-intercepts right there. That's just that part. If you wanted to use the quadratic formula, which it comes out nice and clean for both, even with the square root right there, you'd still get these two x values from the x-intercepts. Right here, we're just asking us to graph, but you need the vertex. So, of course, I'm gonna try to force this to become vertex format. Okay. Okay. So that's my vertex format. Yeah, it's y equals right there, but my vertex, once I have these values, my vertex is hk, and we know if this is plus right here between the x and the h, then it'd be a negative h, and if it's minus k, then it would make that value negative as well. So we're going to start with just the right side of that equation. So I'm going to say it's an expression x squared plus 4x, and again I'm separating the plus 9 so that I have some space, some room to complete this square. And well, let's get started there. So again, I'm looking at just these two terms. I'm going to make it 3 terms, and I'm going to add. I'll put it in here this time. So I'm going to add. It would be b, which is 4 in this case, over 2 squared. Okay, and so my 4 there, the b value, 4 over 2 to the power of 2, which is 4. So let's show this once again, but without that 4 over 2 business. So I've got x squared plus 4x plus 4 over 2 is 2, and then 2 squared would have been 4, which means that I would also need to have had subtracted 4 on the outside there as well. And now I've got 9 minus 4 there, which is positive 5, and that should end up being our k value, but if you wanted to factor that trinomial out, you could. Again, I'm expecting this to be x added or subtracted something squared, and then would still have the plus 5 there on the outside. So 4, what two values of 4 add up to positive 4? It's just 2 and 2. Now it's a positive 2, so I'm just going to put positive 2, which you would have gotten from 4 divided by 2 right there as well. So to complete this equation, I will now write the y equals stuff, but I now have my vertex, at least, which is one of the values you will need on the assignment. So this one is, it's not just 2, yeah, it's negative 2, and then 5. So that's my x and y value. Now that I have those, I'm going to go to the graph. Negative 2, 5, so that's 2 to the left from the origin, up 5. For me, it's right there. And I'm going to put the label here, negative 2, 5. I'm putting it there just because I'm expecting this to open upwards. Now, you only need one other point to graph this on the assignment. So, the one that I choose,
Y-intercept.
yeah, I'm going to choose the y-intercept because it's so great.
It's easy.
I think it is. So here's what this means. Okay, for my y-intercept, you can choose any x value that you want. By the way, you could choose a y value and solve from there, which seems like would suck. But I'm going to choose an x value, and I'm going to choose the easiest one I know of, and that's where I make the x 0. Okay, in fact, both x's then are 0, right? This is really f of 0. So it ends up being 0 squared plus 4 times 0 plus 9er, and then that's my y, by the way, but I know anything times 0 is 0, so I just end up with y is 9. Okay, so this tells me that I have an ordered pair for my y-intercept of 0, 9, which, will fit on this graph. Okay, so 0, 9, found it. It's right there. Now, if you put these 2 points on the graph,
0, 9 is the y-intercept?
if you put this on the graph, that's all you need for the graph, okay? And so we have this point at 0, 9, putting that in because I want to remember it. But because I want to be thorough here, I'm going to choose another value because, I don't know, I'm a math nerd. So I'm going to choose an x value that's negative 1. Okay, so in my value, I got negative 1. If I do this, you can put this into the calculator. 1 minus 4 plus 9er, 6. So it's a negative 1, 6 ordered pair, which would be right there about negative 1, 6.
Why'd you pick negative 1?
The reason why I chose negative 1, which may seem random right now, is because I had an x value that was negative 2. I had an x value that's 0. Naturally, since I can see these two values, I just chose x values negative 1 because it's in between. And
Okay.
I figure it should fit. Now, from this, you're welcome to put in, excuse me, negative 3 and then negative 4 if you'd like. But for me, I'm going to use the axis of symmetry to find the other values on the graph, right? So let's make a line here. If I can figure out how to do that with some technology. It's not a great line, but it'll do. Okay, so I would have the reflected points, or the mirrored points here. That's at negative 3, 6. And then here at negative 4, 9. And that gives me, of course, a lot more points than you're going to need on the assignment to graph. I only need 2. One of them has to be the vertex. But I'm now ready to graph this. Purple seems like it'll show up pretty good. So let's see if I can, hey, that wasn't too bad. And, well, that's not too bad either. I at least got on the lines, on the points, so that's not too bad.
We knew that was going to open up.
So that's how you do it by hand. You would probably want more than just 2 points than if you're doing it by hand, but on the assignment you only need the 2. Right here, again, it's h of t. It's just y equals this stuff, but 2t squared minus 8t plus 6. Well, we have a coefficient of in our leading term there. That's okay. It's all right. It's doable. So again, let's write this down here. So I got 2t squared minus 8t, and then I got a plus 6 over here. Now we did see another way to find the vertex, even from this format, which we're going to see again. But I'm going to pretend like we don't remember that because generally we don't. And from here, I'm going to take, again, these first 2 terms. I'm just looking to complete the square with those 2. But first, I would like a coefficient of t squared that's 1, which means that from that t squared minus 8t, I need to factor out 2. Okay, so 2t squareds divided by 2 would leave me with t squared. And negative 8t divided by 2 would be negative 4t.
Why couldn't you take it,
You don't have to, you do not have to do all this stuff to find the vertex, which we will see momentarily. I'm doing it because, well, not because it's part of the lesson, just because it's part of the lesson, but because I enjoy it, which is kind of weird. So, I still got my plus 6 right here, and I will complete that square. So I will show what is happening here. We're going to add, remember you divide it by 2 and square it. And then when I say it, I'm talking here, it's a negative 4 from the b value, right? So that would then make this. Now I haven't zeroed it out. I will. Don't worry about that. But that would make this t squared minus 4t plus, thank you, plus 4. Now, of course, the inside of that would have been negative 2, which will be important. But right here, we still got that plus 6. I need to zero that minus 4 over 2 squared, which had an overall, it has an overall value 4 right here, okay? It's not an overall value 4 because the 2 would be applied to it from distribution, meaning that this 4 actually has a overall value of 8, meaning the 6, I've got to subtract 8 out of that garbage. Okay, and that then would make this negative 2. So now I have a perfect square trinomial, and that means I could take the t. We still got the 2 on the outside, by the way, and the minus 2. But the two factors of 4 that add up to negative 4 would be negative 2 and negative 2, which means that I have a negative 2. I forgot to put the squared there. Lots of 2's on this one. I don't know if that was meant to happen. 2 2's, so take that. And now I have my vertex, which I need for my graph. My vertex then, again, this minus sign has to be there, so it's really 2, and then the negative 2 right there. H and K, 2, negative 2. That's my vertex. That's great. And now that I have my vertex, I'm going to go to the graph here. Let's put it on there. 2, negative 2, so 2 to the right from the origin down to, boom, vertex. And that, to me, I think that's a good thing, right? We don't actually have to worry about this 2 on the outside that we factored out when we consider the vertex. That 2 on the outside of that, of the parentheses, this red 2 right here, all that does is it kind of just makes this thinner. It makes it increase faster. I'm sorry, I'm talking like a nerd, but now that I've got my vertex, it didn't ask for it, but I would like to see it. I'm going to give myself a axis of symmetry, which has to go directly through the vertex right here. So that blue line is my axis of symmetry. You can say line of symmetry if you'd like. Again, that's where the parabola mirrors over itself. Well, that's great, but I do need another ordered pair to put on this graph, and you'll never guess I'm going to use the y-intercept. So that would make, since I'm looking for the y-intercept, I'm looking for an x value, or in this case, a t value that's 0. Sorry, that got a little sloppy there. You know what? That's fixed. Okay, so I go back to my original equation. Again, it says y equals, it'd be 2t squared minus 8t plus 6. And I think I may be showing more work than anyone or some of you may need.
I like that.
But hopefully it helps. Yeah. So just put this in the calculator, see what you get. And so I get 0, 0, 6. The y value is 6. 0, 6 is my y-intercept, which now that I know it, I can put it on the graph. So 0, 6, from the origin, you just go up 6. That's at 0, 6. Now, of course, I'm doing this by hand, so I do want more points on the graph. And so I'm going to take that equation. We know we got 0, 6. Let's find another one. So I'm going to take out the zeros. Let's put a 1 in there and see what happens. So it'd be 2 minus 8 plus 6. Oh, is that 0? Holy smokes. So that would have been the ordered pair 1, 0, because I chose an x value that's 1, 1, 0. Boom, right there.
What did you go with, sir? 1.
Yeah, so this one, it kind of took on that same format that the last one did. I had a 0, 6 and a 2, negative 2. I just chose an x value directly between that, which was 1. Now, of course, this reflects over that, so I'm going to, this point right here at 0, 3. 3, 0, sorry. And then this one, again, I'm just reflecting it, but that would be 4, 6. Right there. Now, this also means that if you were to replace x with 4 into the equation, you'd get a y value that's 6. Or if you replace the x with 3, you'd get a y value that's still 0, because it's symmetric. Well, that's great. And now that I have all these points, I can't fit any more on the graph. It goes way too high. And it goes really fast. Let's see if I can draw this. Oh, got really sloppy there, but something like that. All right, let's try the other one. Little bits at a time. Okay, that second part I think went pretty good. I got my axis of symmetry, I got my parabola, it's pretty-ish, and I got my ordered pairs right there. Okay.
Would we need the axis?
Okay, if you wanted to just find ordered pairs and you didn't want to put it in the, just calculate that crap all the time, you could, if you wanted to, use a calculator. So this is what you would do. Okay, you're going to push this button right here. It says table. Okay, now if you push table on your screen, it says y. Oh crap, y equals. That's what it says. It's saying y equals. What do you want y to equal? Well, I would like it to equal 2t squared minus 8t plus 6. So I push 2. And then I'm pushing, it's just right to the left of 4. It kind of looks like this. It's the X button. And it's got Y, Z, T, A, B, C, something like this. Okay, so that's my X button. I'm not going to draw it like this again because that was a lot more writing than I want to do. That's 2x, and then you push the X squared button, 1 to the left of 7, X squared. And on your screen, now you see 2x squared. Yeah, but our variable's t. The calculator doesn't know that. Okay, so just use x, please.
How do we get that squared?
Okay, and then we got this minus, so you push the minus button, not the negative button, minus. And you're gonna push the 8 button, of course. And then you're gonna push the X button again, just one button to the left of 4. And then you're gonna push plus 6. Okay, so you can see it now on the screen, it's showing 2x squared minus 8x plus 6, which is exactly what our equation is, just instead of t's, it's x's. Well, that's nice. Okay, now if you push enter, your screen is going to say start. Mine's not starting probably where yours does, but it also says step, which we always want to be 1 for now. And then it says auto and ask, which I don't want to write, and then in the bottom right it says okay. So I'm going to start at 0, just because 0 is always a nice place to start. That means that I want to start at x equals 0 on my calculator. Okay, so I push 0, I push enter, and I want my step to be 1, which is what it is. I push enter, it goes to auto. I push enter again, it goes to okay. I push enter again, and now on my screen, it's showing a table, which is what the table button is supposed to do. So it's showing x, y here at the top, and it says 0, 6,
When I'm
1,
at
0,
flashing auto, Mr. Sell?
2, negative 2. Sorry, and then at the bottom it says x equals 0. That's the value that you're on, okay? Now you do see that it's showing the vertex, but it's not saying it is the vertex. It doesn't know that it's a vertex. You have to find that out on your own. But you can see the other ordered pairs that we found, 0, 6, and 1, 0, 0, 6, 1, 0, those were on the graph. We already figured those out. Just this is a way for the calculators to display all that information in a very quick way. And like I said, on the assignment, you only need one of those values. When you're graphing this by hand, having that come out like that is pretty handy. No pun intended. But if you wanted to scroll up, if I push up, it's now showing negative 116, which doesn't fit on the graph. If I wanted to go down to where it says 3, it says 3, 0. And if I push down again, it says 4, 6. Boom. So the calculator, if you want to let the calculator do that for you again, I think it's kind of quick, it will. And it's happy to do it for you. It even thanked me for letting me do it. Yeah, so this is good to know as well. If you wanted to find these two values, which are just the x-intercepts, they just happen to fall in very nicely with 1, 0, and 3, 0. But if you wanted to find those values, even if they were decimal values, you could use the quadratic formula for that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can enjoy saying that in a fast way if you watch or if you listen to Skank and Pickle. Well, if you had standard form, which is this, you can find the vertex with this formula right here. Now, sometimes students get mixed up and say, well, okay, this is easy enough. Negative b over 2a, and that's fun. We love it.
We did this last week.
Students get confused by this. This is just saying, once you find your x, just find the x first, and then once you have your x, just place it into the formula. That's all, into the function, or the equation that you started with. Because once you do that, then that's what f of this is. It's just saying f of x. You have your x value, just find the corresponding y value from this function or equation right there.
An example.
So this is telling us, again, if you wanted to find the vertex without having to complete the square, it's saying you don't have to, and you can still enjoy it. So for this one, we say it's negative b over 2a. Well, up here, I see a b value that's negative 8. So I say it was a negative 8 right there. And then the a value was 2, remember that? And so it's 2 times 2. Negative 8 over 2 times 2 would be like 8 over 4. So as it turns out, it's 2. Now, if you remember the last example, that's where I pulled this equation from. The x value actually was 2. But now it says, well, find the corresponding y value. So the corresponding y value is where you take the x and then just put it into the equation that we had. So it's 2t squared minus 8t plus 6. So, well, my x is 2, so I just put it in here like this. Put this in the calculator, boom. You'll never guess. You get negative 2 right there. And that was the corresponding y value that we saw in that last example. All right, now you're welcome to find the vertex with the completing the square. But since we saw that stuff with the vertex formula, what I'd like first is to find my x value, right? So I know I'm setting up a vertex, which is really h and k if you complete the square. But my x value is found by taking the negative b over 2a. So here, I see that the b is negative 15. So I'm starting with the b just because it's the numerator. If that's a nasty habit to you, then start with the a value, which is 2. Okay, so in the denominator, we got 2 times 2. I'm going to keep this as a fraction. It's just 15/4, which appears to be 3.75 if you would like the decimal. I don't really care which one you do, right? But I'm going to use the 15/4 because I think the 15/4 is prettier. But some students are like, 3.75 is pretty. Feel free to use it. I don't care. On the assignment, if they want a decimal, they may say, hey, just round it or show it as a decimal specifically. Again, we don't have anything specific here. Geez, I'll do it twice. So we got 3.75 right there. Now, the other ordered pair, then, or the y value in this ordered pair for the vertex can be found by taking the original equation, y equals, I know it's f of x, but I'm making it y, 2x squared minus 15 times x minus 8, but I now have a x value of 15/4, yep. I don't imagine this is going to come out very pretty, but let's find out. I'm just going to put it in the calculator. All right, so my decimal there, because my calculator gave me a decimal directly, negative 36.125, which as a fraction, yeesh, that is pretty ugly. Negative 289 eighths. So when my calculator gave me the decimal, I just pushed the double arrow button above enter, and it gives me that fraction. And it's pretty ugly. Usually if it's that ugly, it won't actually show it to you, but whatever. Okay, so I have my vertex, and that's great. It's not asking us to graph, especially since we have some decimal values on that. What I want next is my x-intercepts. And since I don't want to do any factoring right here, which appears could work. I don't know if it would work, but I'm going to use the quadratic formula on this one. So it's a big fraction, but it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, I already have my a value, right? So that's a 4 times a, which is, up there it says a is 2. It's on the bottom as well. The b value is negative 15, so that would have been a negative 15 there. And then it would have been a negative 15 in here as well. And then the c value shows as negative 8. Now, I put plus or minus on here really just to save some space. I'm gonna do the plus one first. But again, this would be my x value for the x-intercepts. One of them. Okay, so that means that the y value has to be 0, but I'm finding my corresponding x value. Here we go. So it did come out pretty on this one. It gave me an x value that's 8. So that's 8, 0. That's one of the x-intercepts. The other one, I'll do minus now. So I'm just going to go up here, click on my equation, just change that plus into a minus. Oh, it gave me a negative 1/2 on that. So we had x was 8 with the addition, and then with subtraction was negative 1/2.
And to reiterate for our,
Now this coming out as 8 and negative 1/2 means that it probably would have factored pretty well right there. So you're welcome to factor it if you'd like, but I use the quadratic formula. The y-intercept, of course, is always fun because the x value is just 0. So in the equation, 2x squared minus 15x minus 8. Okay, so the y-intercept, of course, the x is 0. So I go in here and I say, well, my x's are zeros there. Right, that's from this one. And when you do this, put this in the calculator. This is my y value, the corresponding y value. Boom, negative 8. So I have a y-intercept of 0, negative 8. Now I'm going to do the same thing, but in the bottom here saying f of 1, which maybe I should have given myself more space. That would have been 2x squared minus 15 times x minus 8. But now my x is 1. So 2 times 1 squared minus 15 times 1 minus 8. And 23, negative 21. There it is.